For question 3, in the diagram IJKL are points on a circle such that angle JIL is equal to 3y and angle KML is equal to 2y. If angle KLM is equal to 55 degrees, find the value of y. This was the question 3a. So how can we find the value of y? Now let's consider the diagram in question. This is the diagram. You have been given the angle at I, that is JIL. That is the angle here to be equal to 3y. Once again, you have been given the angle at M, that is angle KML, to be equal to 2y. You have been given another angle here, that is angle KLM, to be equal to 55 degrees. Now, if you want to find y, you need to consider some properties concerning circuit theorem or cyclic quadrilateral. Let's consider line ILM. This particular line, the line from L up to M. Let's consider this particular line. If we look at this line, realize that it's a straight line. Therefore, angles at a point on a straight line sum up to 180 degrees. So if we are having the angle here to be equal to 55 degrees, then what is going to be the angle at this point? This angle plus the 55 degrees is supposed to give us 180 degrees. So we are going to have the angle here to be equal to 125 degrees, because 125 plus 55 degrees is going to give us 180 degrees. So now we know that the angle ILK will be equal to 125 degrees. So that is the angle here. If that is the case, then we can try finding the angle opposite to that angle, because we know that under cyclic quadrilateral, the interior opposite angles sum up to 180 degrees. Therefore, the angle here and then the angle here, these angles, they sum up to 180 degrees. So you should take note that angle IJK, that is the angle here, and that is angle ILK, they sum up to 180 degrees. So if you know that angle ILK is equal to 125, then we can find our angle IJK, that is the angle here. We can try finding that. Then how do we find the angle IJK? Let's try and make it the subject. So we are going to have our angle IJK to be equal to 180 degrees minus 125 degrees, and this will give us 55 degrees. So it means that the angle here is what? 55 degrees. 55 degrees. if we know the angle at J, that is angle IJK, to be equal to 55 degrees, then let's consider triangle IJM. Let's consider triangle I, J, and M, and this triangle, and see what is going to happen there. So now this is triangle IJM. Don't forget that from our diagram, we realize that the angle at J is equal to what? 55 degrees. Therefore, the angle here, we know that it's equal to 55 degrees. If that is the case, we know that the sum of the interior angles of a triangle sum up to 180 degrees. Therefore, angle JIM plus angle IJM plus angle IMJ, this is supposed to give you 180 degrees. If that is the case, angle JIM, which is the 3y, plus angle IJM, so IJM, and that is the 55 degrees. So 55 degrees plus angle IMJ, and that one too is 2y. This is supposed to be equal to 180 degrees. So with this, you simplify, or you group like terms, then you simplify it further. 3y plus 2y, this is going to give us 5y. So you have 5y plus your 55 degrees, and that is equal to 180 degrees. Don't forget that we are solving for y, so we are going to make y the subject. So here we are going to get our 5y being equal to 180 degrees minus 55 degrees. This will give us 5y being equal to 125 degrees. You are solving for y, so what do? We divide both sides by the coefficient of y, that is a 5. We divide this side 2 by 5. Therefore, this 5 is going to cancel this 5. And this is going to give us y being equal to 25 degrees. So this is how we can solve for our y, or get our value for y. And that is the question 3A of the Wassce 2020, the core math theory paper. Now let's try and move to the B of the same question. That is the question 3. For the B, given that tan x is equal to 1 and 0 degrees is less than or equal to x less than or equal to 90 degrees, evaluate 1 minus sine squared x all over cos x. Now in this case, you have been given tan x, but the x falls within a range. If you consider the OXY plane from the information given, x is in the first quadrant. If we consider our OXY plane, x is going to be in this first quadrant because it falls within 0 degrees and 90 degrees. So x is going to fall in this quadrant. Don't forget that in this first quadrant too, all the 3 trigonometry ratios, they are all what? Positive. So we're going to assume our triangle in this quadrant. Okay, so we put our x here. We were given tan x, and per this tan x being equal to 1, it's same as 1 over 1. So in this case, we know that tan x is opposite over adjacent. So if this is our x, opposite to this particular x, which it's assumed to be an angle, is this particular side. Therefore, we are going to have our 1 here. And then the adjacent, this side is the adjacent. Therefore, the adjacent is also what? 1. Now, before we find the value for sine x and cos x, unless we know the third side, which is the hypotenuse. So how do we get a third side? From what we are having here, let's assume that we have our point. Let's say we have 0 here, we have A, and we have B. And we know that from the Pythagoras theorem, our OA squared, that is the length of the hypotenuse squared, is equal to OB squared, that is the length of the adjacent, plus BA or AB squared. That is from Pythagoras theorem. The square of the hypotenuse is equal to the sum of squares of the other two sides. So in this case, we want our OA, the magnitude or the length of OA. So let's maintain that. So we are going to have our OA squared being equal to OB was 1. So we have our 1 squared plus AB, which is also 1, therefore 1 squared. This is going to give us 1 plus 1, and this side is going to give us 2. So it means that we have our OA squared to be equal to 2, but we want OA. So in this case, it means that we need to take square root of both sides. Therefore, our OA will be equal to square root of 2. So it means that from our diagram, which is not drawn to scale, this side being our x, this side is root 2, this side is 1, and this side is also 1. Therefore, if we want sine x, we know that sine is opposite over hypotenuse. Therefore, this side is our opposite. So it's 1 over our hypotenuse, which is the root 2. So that is root 2. Once again, if you want cos x, cos is adjacent over hypotenuse, and our adjacent is this 1. So 1 over hypotenuse, which is the root 2. So our cos x is equal to 1 over root 2. Sorry. Now the question wants us to evaluate (1 minus sine squared x all over cos x). So all that we have to do is to substitute the values for sine x and cos x respectively into the expression here. So we are going to have 1 minus sine x was 1 over root 2. what we are having here, the sine squared x, it means that we are going to square the sine x. So we are going to have our 1 over root 2 all squared over our cos x, which is 1 over root 2. So we want to simplify this. Now for the numerator, 1 minus 1 over root 2. This squared is going to affect the 1, so 1 squared will give us 1. And the same square are going to affect the root 2. Root 2 squared will give us 2. So we are going to have 1 minus 1 over 2 all over 1 over 2. So for the numerator, 1 minus 1 over 2 is going to give us 1 over 2. So I'm going to have 1 over 2 divided by 1 over root 2. You simplify this further, you have 1 over 2 that is divided by 1 over root 2. And this is the same as 1 over 2 times root 2 over 1. And this is going to give us 1 times root 2, that is root 2 over 2. And this is our final answer for the simplification. This brings us to the end of the question 3 of the Wassce 2020, the core math theory paper.